So, there's a problem with the piano. Producers use MIDI controllers to talk to their digital audio workstation, and even though these controllers come in multiple different shapes and sizes, almost all of them use the same basic piano layout. This basically forces you to learn how to play the piano and all the music theory associated with it. On top of mixing, mastering, sound design, and audio engineering, you're expected to learn different scales that keep changing shape, weird fingerings that shift from key to key, and chord intervals that keep you counting notes instead of just playing. This convoluted and unintuitive piano layout can make production a nightmare. That's why I built this. Before I show you the controller, I want to explain why I built it. So on a normal piano, something like this, the layout just isn't very intuitive. So the intervals don't line up in any consistent way because the white keys and black keys aren't spaced evenly. So two major chords might have the same interval formula of a note, a root note, 4 semitones, 7 semitones, but the physical spacing that your fingers actually have to travel changes depending on where you are. So let's hop into Logic and just look at a quick example of what I'm talking about here. So if we look at the key of C major, it sits neatly on all the white notes. If we go to D major, it forces your fingers to start playing some of those black notes, even though it's the same spacing between the notes interval wise. So D major actually has 2 black notes where C major has no black notes. And unless you spend the time to count between each interval and each root note or learn all of the scales differently, it's very counterintuitive to start playing. So C major again uses all white notes, just the chord. But C minor adds in a black note, whereas D major adds in a black note, and D minor uses all white notes. So the instrument is literally changing beneath your hands while you're playing, and it makes it very complicated to learn. So that complexity of learning how to play the piano is what inspired me to build kind of my own personal MIDI controller. It just keeps everything a lot more consistent and lets me change keys instantly and kind of removes all the friction of playing the piano, counting intervals, or avoiding all those weird piano fingerings. It just lets me stay in the flow and focus on making music. So let's take a look at it and I'll show you what it does. Okay, so this is the MIDI controller that I built. As you can see, it's pretty basic. It has 8 buttons at the bottom. These are arcade buttons. It has just 2 simple switches and then 2 knobs here. And we can start here on C major, and each button will play a note of the C major scale. And this first switch here changes it from chord mode and note mode. So right now it's on note mode. If we flip it, it'll now play the chords of the C major scale. This second switch here toggles between major and minor. So if I wanted to go back to note mode, and now I want to play C minor, and then similarly, I can play the chords of C minor. And these are playing the diatonic chords. So it's sometimes in a major scale, there's minor chords. The whole purpose of this MIDI controller is that it removes that complexity. So moving on, we're back at C major here. This next knob changes the root note. So right now we're on C3. And it goes by semitone. So if you move it 1 up, 2 up, we get to D. And then subsequently, all the buttons follow the same logic. So we're in D, we're in major, we're in note mode. So to play the notes of D major. Again, I can play the note, the chords. Go to D minor. And I can do the same thing, up the entire keyboard. And the last knob here is for octaves. So again, we can start at D. And again, it will play. So again, the whole purpose is just to reduce the complexity, make it a lot simpler. Just play some chords, play simple melody, and go to creating music. So let me show you how I actually built this MIDI controller. So the first thing I did was going to design a case that I was going to 3D print. So I had to use some computer software to make a 3D model. This part for me was by far kind of the longest process of the entire build. It took a long time for me to just learn how to use the software and get it to do what I wanted it to do. And after many iterations of trial and error, I was actually able to get a working product. So let's just hop into Fusion and take a look at what I actually designed. And so this is the bottom plate here, or the bottom case. It's pretty simple. It's just a box. It has these 4 corners to put some heat set inserts in there to screw down the top plate. And then it has a little cutout here to put the cord through to connect to the microcontroller. And so this is the top plate. This is a little bit more interesting than the bottom. This is what has all the cutouts for the actual buttons, knobs, and switches. It's about 2 millimeters thick, so all the buttons just kind of pop straight into there. Then I also built these 4 additional standoffs so I could screw down the microcontroller, directly onto the top plate. And again, after many hours of design, this is kind of what I came up with. So next up was writing the code, and this part was actually pretty easy because I was able to leverage a good friend, and they were going to help me with writing it and designing and troubleshooting everything. And so this part was surprisingly straightforward and easy. Yeah, so this is kind of what the full code looks like. And this process was very straightforward and very easy. It had a couple minor hiccups with just kind of explaining what I wanted and how I wanted it to be done, and some small errors when I tried to compile it. But after just taking a couple screenshots and plugging it back in for feedback, again, this was very straightforward and did not take long at all. It took longer to kind of think of the layout and design I wanted than getting AI to actually code it. And I have very limited actual coding experience. This was pretty much 100% vibe coded. I don't really understand what is happening or how it's working, but I know it's working how I intended. So this was a very fun project to do, and very surprised with how it was able to create this code. This here is the actual code I used. That one I just tried to have it pull up from memory, but this is the code from a few months ago that I built, and I'll have a link to the actual code in the description if you guys are interested in kind of what that looks like. But here's just a quick overview of the code. Moving on to the soldering. This was my first time ever actually using a soldering iron, and so this was pretty intimidating to start out. It turned out to work out just fine though. What we're doing here is just a direct wire build. So each button, knob, or switch is just going to its own pin on the microcontroller, with the other pin going to the ground. So what we did was kind of daisy chain the grounds all together, and then they all share the same ground on the microcontroller. The knobs were a little tricky because they have 4 pins, so there's one for up, one for down, and then one for ground. After cleaning up kind of a few soldering bridges, this also just kind of worked kind of the first time. So this was, pretty straightforward. This was pretty fun. Definitely not the best at doing it, but it worked out. And yeah, this is kind of what that looked like. Okay, and so now we're going to do a quick demo in Logic and show you this MIDI controller in action. All right, we're just going to pull up Arcade Output. Let's go to chord mode. And we're just going to get a snare in for some bounce. Alright, we're just pulling up another thing of Arcade here just to get some more depth on those chords. So let's just find... Just adding a little bit more texture there. Now let's just add another counter snare. Let's look for one more Arcade, and now we get to the fun part, and we're gonna try to make a little melody here. All right, so now we got this flute loaded up, and now we're just gonna play around until we get, a melody that sounds nice. And kind of the fun part about this is that nothing's out of key. You can't really play a wrong note now. Just gonna get a hi-hat in here. All right, and so here's a full listen of the quick beat using this controller. Alright guys, and so that's pretty much all I have today. This was just a quick breakdown of kind of how I built this controller, the 3D printing, the wiring. If you want the files for any of those, I'm going to leave a link in the description. If you guys like these types of builds and want to see stuff more like this, make sure you like and subscribe. I've got a nice idea for another build coming up, so catch you guys in the next one.